Okay, so today we are starting with module 1. So it's day 1, module 1, and we are going to cover the SM.I.LE80 system architecture. So we're going to present you which are the main components that make up a SM.I.LE80 system and how they are connected together, how they can work together to accomplish their functionalities. Then we are going to describe the deployment architecture, which is actually which are the physical machines, which is the difference between a high availability versus a basic configuration without redundancy, and where actually the components that we described in the first module in system architecture, how they are actually running on real virtual machines, so how they are distributed and so on. Then we will have a break. Sorry, before the break, of course, we will have Q&A sessions. Q&A session because we are, let's try to keep, let's say, the presentations as clean as possible because they will be recorded and reused for other people. So we will try to answer to all the questions in the Q&A. Probably I think it's probably easier to have a Q&A session after each single presentation so that you don't have to remember too many things for too long time. So we can maybe have a Q&A session after system architecture and another one after the deployment architecture. Then we will have a break. And after the break, we will start again with the SM.I.LE80 installation procedure. So how to obtain a working SM.I.LE80 system and where to find the documentation. You need to follow this procedure. And finally, we have a session regarding security, so authentication, authorization, and security more in general, how it is managed in SM.I.LE80. Okay, again with the Q&A session. Okay, so I think we can get started. Sorry, Enrico, you will be taking care of noting down the time for the academy. Or okay, so let me share presentation. Okay, so let's start with the training module 1, system architecture, SM.I.LE80 system architecture. So in these sessions, we are going to describe which are the components that make up a SM.I.LE80 system, how they are connected, and how they work together. So these are the learning objectives of this session. So after this module, you should be able to describe which are the components that create a SM.I.LE80 system. Tell which components are open, so can be customized for the project needs, and which are closed, so you cannot customize based on project needs, but they are general platform components. We will try to understand the functionalities provided by each component and understand how they are connected together. We will learn how to restart and execute individual APIs. And finally, we will have some slides regarding the RabbitMQ message bus, which is its role and how we can monitor it through the management interface that is provided by RabbitMQ. In this module, we are going to have quite a few diagrams that show the components and their connections, and we will consistently follow this color key. So when you see components colored in green color, it means that these components are closed. So they are distributed as executables, and they cannot be customized for the project. So these are components that are released by the SM.I.LE80 team, and the project team cannot modify them. Open components, on the contrary, which are highlighted in yellow color, can be customized by the project team. And okay, we will see which they are and what customization can be done. We have another class of components that is the dark gray. Dark gray is a component or a software that is anyway owned by E80 group, but it's not in SMILE80 scope. So, for example, Smart is a software that is owned, of course, by our company, but is not part of the SMILE80. And finally, we have the third-party software, which is software that is coming outside our company. Okay, this is colored in light gray. Okay, so we have close in green, open in yellow. Okay, I will anyway restate this if needed. And dark gray is E80 outside SMILE and third-party in light gray. So since the SMILE80 architecture is quite complex, there are a lot of components making up the architecture. We're going to split it in blocks. So we're going to start with the front end, which is the top layer of the SMILE80 stack. And the front end is composed by these blocks. So as you can see, there are some third-party tools like Minio, Load Balancer, and the LDEP. And there are closed components, so components that cannot be customized, that are the web UI, API gateway, identity server, and security server. These blocks have two different functionalities. Let's say that all the authentication and authorization is taken care from the identity server, LDAP server, and the security API, and the security database. So these blocks on the left are basically dedicated to security. On the right-hand side, we have some blocks that are providing common services, such as front-end access, the routing toward APIs, and load balancing, and now we will see a menu for some object storage. Okay, so if you see the diagram here, you will see the same diagram on the top right corner here, highlighting which module we are covering on each slide. So we're going to start with the web UI. Web UI is an application written in Angular. It is a web application that implements the web UI application, of course. So it is the application that you are actually running when you connect with the SMILE system. Download and launch it is simply you are required to write inside the address bar of a browser HTTPS and then IP address or name, DNS name of the load balancer. So this is simply how to launch the web UI. Load balancer, as we will see later, is the place where all the HTTP connections are served. Okay, so it's our main server, web server, let's say. Okay, so the web UI basically provides to the customer, to the clients, access to the 3D layout, 2D layout, all the configurable pages, and all the actions and commands. It's our main interface. Okay. Okay, we have another couple of components, the load balancer and Minio. Load balancer is the server that takes care of all HTTPS requests coming from the web UI. So the web UI connects with the load balancer in, as we will see in the deploy architecture session. If you have a high availability configuration, actually there are two different load balancers. So they are redundant, let's say. But for now, you can think of a single point. It's really the entry point for all HTTP requests, and it's secured. So the web UI accesses to the load balancer with a secure HTTP. Load balancer is based on Nginx. It is a component coming from a third party. And it acts as a reverse proxy, routing all the requests to the appropriate server and port. Specifically, it is able to connect the web UI to the web server, to the API gateway for API requests, and for authentication, it redirects toward the identity server. And in addition, requests on Minio are routed to the port 9000 that is controlled by Minio. Okay, so basically it's really a reverse proxy, a sort of router, we could say, that connects the web UI to the appropriate server. Okay. Minio, okay, we will really talk really little about it. Is a component that also is third-party tool that manages object storage services, and in particular, it is a repository for users and role avatars images. So in SMILE80, you can assign to a user or to a role a picture, an image that represents the user or the role. These images are physically stored on Minio. Okay, so that is it for the, let's say, the common services inside the front end. Okay, now we will move on the left-hand side and have a quick review of all the components that take care of security. So we have 4 different components. Of course, the core for everything is the security database. The security database is a database that stores all security information about SMILE80. So all the users, all the roles, the permissions, and all the mappings are stored here in this database. The identity server is a server that receives the token requests. So the token is a sort of, let's say, request for authentication from the web UI. So web UI, the user will provide the username and the password, which will translate in a token request toward the identity server. The identity server will then check the correctness of the user's credentials inside the security database and return, of course, an error in case the credentials are incorrect, so the user does not exist or the password is incorrect. Otherwise, it will return a token that will be used from the web UI also to call all the APIs. So every API request almost is secured with this token. There are actually some API requests that do not request authentication, for example, because they are invoked before the user login, so you still don't have at the moment the credentials. But the major part of API requests are actually authenticated. So the identity server will mediate every API request and check if an API request is actually permitted or not. Okay, so the role of identity server is to check user credentials and return the token, while the security server is the one that checks actually the authorization. So it checks if a user is actually enabled to do something. So the security server contains the operations that support user creation, removal, and role management, and so on. Create, read, update, and delete. And it also supports the user.SME API that returns the user roles and information to the web UI. Okay, so these are the main blocks. The LDAP server is used only for authentication purposes, so the validation of credentials, because SMILE80 supports also external authentication. So with SMILE80, you can use, instead of the users defined in the local database, you can use an LDAP server that is outside, of course, the security database to validate the user's credentials. Remember that the LDAP server is only used for authentication, that is username and password. It's not used for authorization, because authorization is entirely managed by the security server and the security database. Okay, so roles, permissions, and all of that is actually managed by our implementation, not by LDAP. Anyway, we will hear more about the security section in the next section after the break. Okay, finally we have the API gateway. So the API gateway is a component that is able to take requests from the web API. So web API is making a lot of calls on the API layer, but all the calls are on the same port. So you can think of the API gateway as a sort of demultiplexer that gets all requests on a single port and routes them on the different ports. So as we will see in a few minutes, on the BFF layer, we have a set of different APIs that run, actually that expose different ports. They are all in the range from 8,000 up, so 8001, 8002, and so on. For example, if a user calls the diagnostic API, he doesn't need to know which is the port on which the diagnostic API is running. The request will be done on the API gateway. The API gateway knows that diagnostic is on port, I don't know, 8012, and it will route the request on the diagnostic API, and similarly for all the others. So it's really sort of, let's say, router that connects with web API request with the actual API implemented each request. Okay, this is it for the front-end part. So just to recap quickly, so we have web UI, which is our graphical client that uses services from the identity server for authentication, services from the security server for authorization together with the security database, and LDAP server, which acts as an external authentication server, the load balancer, which is a reverse proxy that say hides the backend and is able to connect the front end with the backend. And we have Minio, which is a repository for images, and the API gateway that is able to route each API request to the correct API. Okay, so this is still the top part. We are now getting inside the BFF. Okay, again, you have the full picture here. You can follow on the top left of, oh, sorry, I didn't put it. Okay, I will connect with this image anyway, never mind. Okay, backend for front-end. So BFF stands for backend for front-end, and this high level, it is a layer that is sitting between the front-end and the backend. Okay, there are part of the BFF is open, so you can customize it based on project needs, and it's called the BFF project. Part of BFF is closed, so cannot be customized, and it's the BFF platform. Okay, they are both based on .NET and C#. BFF platform actually provides basic services that do not depend on the business logic of a warehouse, so you should not need actually to customize it. On the contrary, the BFF project contains modules that depend on business logic, and they usually, of course, you can customize it and implement the logic that the customer requires. Okay, so high level, you have the web UI accessing to load balancer and API gateway, which in turn call the BFF layer, which is in communication with databases. And the BFF also communicates with the message bus that is RabbitMQ. A quick note, even if it will be restated in the deployment architecture session, the BFF is actually a collection of different applications that are deployed on IIS. So what you have is the different API groups, for example, BFF alarms, client configuration, diagnostic, dictionary, handling, and so on, are actually exe executable files that are running as sites inside the BFF. So each API group is a standalone application called a site inside IIS. They are all installed in the same place, that is C-inetpub www-root SM.I.LE80, and they all log under C80 group logs API. So there is a single point of installation and there's a single point of where to find logs. In case you need to restart the BFF, you have two options. You can either restart all the site, the global one, so all the sites at the same time, selecting root and clicking on restart or stop and start, which is the same. Or you have the option to select an individual API group and stop and start or restart individually. So sometimes, for example, restarting the layout or LGV system or handling system could be required. So in this case, you just need to open a remote console on the BFF servers and restart the APIs as needed. Also, from the IIS, it's very easy to identify which is the port on which a given API group is running. You just need to select it, and you will see here on browser website, you will see the port, in this case 8113, I'm sorry, where this specific API, so the LGV system, is running. And this information is quite useful because there is an embedded tool which is called Swagger. That it is installed out of the box together with SM.I.LE, so you don't need to install it separately. That can be used in case of need to call individual APIs. So you are able to invoke every API of this list, every API group and single APIs, browse them and execute them, also testing your own ones if you are creating new APIs, simply typing inside the browser address bar HTTPS, the IP address of your BFF server, and the port on which the API group is running, that is this port in this case, and /swagger. Okay, this is an example. So HTTPS IP address colon port /swagger. You can authenticate using the authorize button here, using, as we will see later, E80 administrator user and your web UI credentials. And then you click on try it out and execute to run the API. Okay, so this is a quite useful tool if you are unsure whether an API is not responding correctly, or if you want to test your own ones, of course. Now, so we said that the BFF layer is composed of BFF project and BFF platform, but as we saw in IIS, it's much more complex than a couple of blocks. It actually contains a lot of different APIs. So what we are going to cover now is to talk about some of them, some individual APIs, which are particularly interesting for the functionalities provided to the system. Okay, so we have three APIs that are the SignalR API, the Alarms API, and Layout API. So these three that are interesting because they are actually supporting event notification. So these three different APIs open a connection toward the web UI, the client, which is a connection based on SignalR. And each of them sends some type of events to the web UI. So for example, the SignalR API notifies generic events like user creation, role creation, changes on pages, and a lot of different security-related and page-related changes. So what the SignalR API does is it opens a notification hub connection on SignalR toward the web UI, which is the pink dashed line here. And it will notify all changes in the security and pages area. Similarly, the Alarms API opens another connection, not the same one, another SignalR connection with the same protocol toward the web API, and it will notify alarms through the hub SignalR connection. Finally, the Layout API does a similar work for location, footprints, positions, and other objects like GP position, recharging stations, and so on, using the Layout 3D hub connection. Okay, if you open the browser's console, so the developer tools, and you navigate to the network tab, clicking on the WS, the WebSocket tab, you will see that these three connections are established: the Layout 3D Hub, the Notification Hub, and Hub. This is important to know when, for example, you are not seeing any event on the web UI. So typically, when, I don't know, the LGVs are not moving or alarms are not coming, this is one possible problem that the SignalR connection is not there. So be aware that these APIs open actually connection with the web UI to notificate different event types. Okay, now we will talk about another very important API, which is the LGV system. LGV system, here you have a more detailed picture. LGV system actually opens a direct connection using the WCF toward the LGV manager. So they are directly connected. Actually, LGV system, and also it connects directly to the LGV manager database. LGV system supports critical functionalities like monitoring of LGVs, all the objects related to LGV manager like active locations, battery chargers, and so on. In addition to that, it exposes actions that you can do on LGVs, like send them to force battery mission, enable or disable missions, cancel a mission, and so on. So when you are doing an action on the web UI on LGVs, you are actually passing through the LGV system API. Also, it sends updating information on the status of active location and status of LGV and position through the Layout API, which is another API using RabbitMQ. So LGV system will gather information from the database, and LGV manager will push changes, events to the RabbitMQ bus, and the layout will receive through RabbitMQ the same event, and then it will forward it to the web UI. Okay, so if you have problems on LGVs, like you are not able to see LGVs on the layout, you're not able to see active location, batteries, and so on, the first place to look at is the LGV system API, see if it is working, if it is connected to LGV manager, and so on. So everything related to LGV will pass through this API, a very important one. Okay, then we have a sort of sister of the LGV system, that is the Handling Systems API, because Handling Systems is pretty much the same as LGV system, but for HDSM, so the High Density Warehouse. In particular, the cranes and the smart stores. So the Handling Systems API will connect using WCF with HDSM, so the backend application that actually manages the stacker cranes and the smart stores, and will also directly connect to the HDSM. So it has a role that is very, very similar to the one that LGV system has for LGVs. Again, it exposes all the actions you can perform on HDSM, it provides you updates, and so on. Okay, this is the primary role of Handling System. In addition to that, Handling Systems also supports let's say, the displaying, the visualization of the background image of the warehouse in collaboration with the layout service. So the layout service gets the information from Smart, and then entering system gets information from layout service and provides the background image. So it is another functionality provided by handling system. Okay, so these are the main APIs in the platform area. So all these APIs, remember, they are not customizable because they are all in the BFF platform side. In addition to that, you have several APIs that are customizable in the BFF project side. Okay, so we covered the top layer, we covered the middle layer, the BFF. Now we are going to spend a few slides on an important component of the system that is a third-party component, that is the message bus RabbitMQ. As you can see, RabbitMQ connects all the BFF APIs one with another, and it connects the backend services such as the SDM, LGV Manager, and HDSM. So it's really a communication backbone. Okay, this is basically the same I already said. So all these APIs can talk one with another using the RabbitMQ infrastructure. So each API connects individually to the RabbitMQ. In addition, SDM, LGV Manager, and HDSM can talk together using RabbitMQ. Okay, the fact I would like to stress here is that RabbitMQ is a critical infrastructure. It's a critical infrastructure because it will allow, for example, SDM talk with LGV Manager. If it goes down, if it doesn't work, SDM and LGV Manager will not be able to communicate, or the APIs will not be able to communicate together, and so on. So what happens is actually that the warehouse could stop working completely because the requests from SDM will not reach LGV Manager. They will be isolated between one another. So it's very, very important to understand how to use this message bus, how to check if it is healthy, and how to address an issue if it is not healthy. To do this, we have a tool that is the RabbitMQ management console that can be accessed using HTTPS, the address of the IP address of the server where RabbitMQ is running, which is typically core server 1, and port 15671, which is a fixed port. Okay, so if you type this address in the address bar, you will be prompted for username and password. Okay, how can you know the username and password? We see it during the installation session, but actually it's defined at installation time. So at installation time, when you install SM.I.LE80, you will set the values for username and password also for RabbitMQ console. So it's very important to remember these credentials, because you will probably need to at least to check the health of RabbitMQ during the life of the warehouse. So it's something that should be kept and saved in a safe place for the entire lifetime of the plant. Okay, now we will see a bit how RabbitMQ is working. So we have actually two different configurations. One is this one that is supported by the HA configuration when you have multiple core servers. Of course, we will review it during the deploy architecture session later. In this case, you have three different virtual machines that I called here node 1, node 2, and node 3 that are actually the core servers. And RabbitMQ is running on each of them. So you have free, let's say, free installation of RabbitMQ, and they are all connected together, and they form what is called a RabbitMQ cluster. Inside the cluster, each node is connected in a point-to-point architecture with the other two, and they talk on port 25672. Okay. And there is a specific protocol that is defined by Rabbit, a proprietary protocol from Rabbit to establish this communication. Okay, these ports are the ones listed here as clustering. These three ports are actually these three connections. In addition to this, you have the clients because, for example, the BFF APIs, the BFF APIs are not actually running a server, RabbitMQ, but they are connected as clients. So we will make a connection toward node 1, node 2, and node 3 here using the AMPQ protocol and port 5671, which is secured. So let's say the RabbitMQ infrastructure in this case is made of 3 different nodes that are all connected together, and the BFF APIs are connected as clients to each node. There is another configuration that is simpler. It is called the basic configuration, in which SM.I.LE80 has no redundancy, has no HA. In that case, in that configuration, you have only node 1. You don't have a cluster, you just have one single node. Okay, so you just have to remove node 2 and node 3, and the architecture is the same. You have one single node, no connection on this port 25672, but only client connection from the BFF. Okay, all these items are actually visible on the RabbitMQ console. So you have node 1, node 2, and node 3, which are these three. These are the Windows names, the Windows host name of the 3 servers, node 1, node 2, and node 3. And if they are colored in green, it means they are running, they're working. If you see them in red or yellow, means that there is something wrong. So red means they are down or they're not reachable. In yellow means that they are starting up or shutting down. So it's an intermediate state. So here in the main screen, you have the overview, and you can see the list of nodes. You can see the name of the cluster because the cluster itself has a name, for example, this one. And you see that you're logged as admin. Okay. So that when there are infrastructure problems, you can go inside the management console and see if there is a node that is not running. Okay, so we say that we have these nodes that are connected together, that there are client connections, but what happens on this infrastructure? It is a message broker. So there are some messages that are some like mails, let's say, that are exchanged between the different servers and the clients. So there is a producer that is sending messages. And then there is an object called exchange that is forwarding the messages to some queues. Okay, typically inside SM.I.LE80, the major part of queues is of fanout type. Fanout means broadcast. So when you send a message to a fanout queue, to a fanout exchange, it will be sent to all the queues. Okay, so you have, as we said, these 3 servers. Each server has a set of queues, and when a message is sent to the nodes, it will be exchanged to all the queues of all the servers. You can see both the exchanges and the queues using the management console provided by Rabbit. So for example, here you see the exchanges. As you can see, there are a lot of exchanges, one per each API. So for the alarms API, bin packing, client configuration, and so on. Each of them has an exchange of fanout type, which is sending messages to all the queues. And you can see that there are multiple queues inside Rabbit. The most important ones actually are the latest. I hope you can read them. They are the queues that are used to exchange messages between LGB Manager, HDSM, and the SDM. SDM, for historical reasons, is called WMS, which is the same as this SDM. You can consider them as synonyms. So these queues actually are used for SDM to communicate with HDSM and to LGV Manager. And these are the queues that LGV Manager and HDSM use to communicate with SDM. Okay, this is a detail from the last slide, so the last part, so we can talk about it a little bit. These 4 queues are mandatory, of course, if you have HDSM installed, because HDSM is optional, so at least you must have the WMS to LGV and LGV to WMS queues. If you have also smart stores or cranes, you must have also the other 2 ones. And it's important to check if the state is running, because if they are not running, there is a big problem. So they must be running. And also it's better to check if there are messages in ready state. So this is a picture of a healthy condition where you have a message, all the queues up, and they're running and they're exchanging messages correctly, and the messages are not getting queued. If you have messages in ready state, it means that they are accumulating inside a queue. So the consumer is not reading them. And remember that messages that are not consumed are in memory. So if these queues get bigger, they are actually consuming system resources. And it could be a problem. It's a memory allocated by the RabbitMQ services. Okay. So if there are anyway problems, infrastructure problems, communication problems between different services, it's very important to check the status in RabbitMQ and try to understand which is the reason of the problem. So this is one point that needs to be monitored in a warehouse. Okay, so this is all about RabbitMQ. So it's a very important critical infrastructure. And remember that if it doesn't work, there are big problems on the warehouse, because it's used also for SDM to LGV Manager communication. And finally we have the backend. I think that this is probably actually the part of SM.I.LE80 that you know better. So the backend, of course, is very, very important because it contains all the backend services that are actually the ones that manage the warehouse, that manage the LGVs, the equipment, the PLCs, and so on. And also the backend also hosts all the databases. All the databases are inside the core servers. Okay, so okay, in the backend, we have core services like SDM, that is also known as WMS, that is Warehouse Management System. You will see both terminologies, both inside the APIs and inside the service name and so on. So consider them as the same. The SDM, of course, is the service and the database that actually implement all the business logic inside the warehouse. So they have the route input away rules, everything that is required to manage properly the warehouse. It is an open module, so especially the T-SQL code that contains the major part of business logic is customizable based on project needs. And as you know, it keeps track of all the movements of the stock units. It manages items, queues, load dates, all the items that are relevant for the warehouse, the shipping, the staging areas, and so on. In addition, it has an interface toward the ERP that is also known as host, where it receives instructions related to the warehouse, like a shipping request or a creation of an item in the item master table and so on. Okay, the SDM runs as a Windows service and is connected to the SDM database, where we have a lot of actually code, T-SQL code. Okay, then we have a bunch of services that are related to LGVs, LGVs management. They are LGV Manager, Smart, the LGV Manager database, and Smart Events. So this part of the system is responsible for the management of LGV equipment and LGV missions. So everything that is related to the LGV world, and also to active location chargers and so on. LGV Manager is also customizable, so it's an open component. It's managed as a Windows service. While Smart is also a mandatory part of the system, so it's the one that manages the LGV traffic, so it's required inside SM.I.LE80, and they are directly connected for the management of LGVs. The Smart Events service is a sort of, let's say, forwarder that takes the alarms from the Smart DB3 database, and it copies on the LGV Manager database. Okay, so it is also running as a Windows service. Okay, that is it for the LGV part of the backend. We have then the HDSM that is required if there is at least a stacker crane or smart store. This is an optional part of the system. So if you have a customer that doesn't have any stacker cranes or any smart stores, HDSM will not be installed at all. You will not have the HDSM database. If you do have it, it is an open component, so it is customizable. Okay, and it is connected as the other ones to the RabbitMQ message bus and the handling systems API, as we saw before. Layout service is another Windows service that is providing the background image of the API to the handling systems. So we discussed it a bit before. Okay, so if you have issues in how the layout, the background image is displayed, you might want to look into the handling systems API and the layout service. And finally, to complete the backend services, we have the reporting area. Reporting will support the creation of reports. We have these items inside SM.I.LE80. So we have the reporting service, the automatic reporting service, which are two Windows services that are pretty much executing the same, but in different ways. So they both connect to all the databases, to LGV Manager, STMDB, STMDB history, and HDSM is if present, MMS if present. And they get information regarding everything, regarding alarms, regarding missions, and so on. And they provide PDF reports to the invoking clients. The difference is that reporting service is creating reports on the fly for the web UI. So the user using the reports menu item will ask to reporting service to generate a report, for example, I don't know, mission flows or LGV availability report and so on. And the reporting service will invoke the appropriate stored procedures on the appropriate databases and collect all the information and return a PDF directly to the web UI. The automatic reporting service is doing the same, but in an asynchronous way, so in a scheduled way. So you can pull daily reports or weekly reports or anyway schedule them without any interaction with the web UI. And then send them to an SMTP server, so send them via email in a scheduled fashion. Additionally, we have the report configuration Windows client that is a client that enables the user to configure the reports, so to choose which information is displayed and which is the scheduling, which is the SMTP server, and which are the recipients of the automatic reporting service. All of these are part of SMILE. They can be installed. They cannot be customized based on project. They are out of the box, and that is it. Okay, finally, so we are toward the end of our training session. This is the full picture. So these are all the pieces together that we described so far. You have the say access part, front end, and the BFF layer, reporting services here, and all the backend services down to the equipment. Okay, so this full picture is also depicted on the troubleshooting guide. So inside the programming guide, there is a support section where you can find the full architecture of SM.I.LE80 and a brief description of each of these modules if you need to, to remember which is the functionality provided by each of them. Okay, so you can scroll down the programming guide. This will be shared with you, of course, and click on SM.I.LE80 architecture for this information. Okay, so let's sum up and close the training session. So what we covered today is the SM.I.LE80 system architecture. So which are the software components that make up SM.I.LE80. So the main part are the web UI that provides access to the warehouse layout and pages. We reviewed briefly the authentication authorization performed by identity server and security server, which are, by the way, two APIs that are running on the BFF as well. So these are actually two API groups as well. We have the API gateway that is a centralized access point for all the BFF APIs and routes your request to the proper API. We saw how the APIs are running on IIS, how you can start, stop, restart each of them, all of them together, and find the port related to each API. Finally, we spent some time on the RabbitMQ. So this is a critical infrastructure message bus that connects all the APIs together and the backend services among them. Such as SDM, LGV Manager, HDSM. And finally, we have the reporting service, automatic reporting service that use the SDM SM.I.LE80 databases to generate reports. Okay, so thanks for attending this session. I think we can stop the recording. And I guess we can take some questions now. So if you have any specific questions before moving to the next topic, that is the deployment architecture, I will be happy to answer. Or also, I don't know, Enrico or Giuseppe, if you have any point that I missed during the presentation, also I can maybe add on that.
I have actually two questions.
Yes.
Just to understand, where is the security server situated physically?
Okay. Yeah, I think that part is covered by Giuseppe's presentation, right, Giuseppe? But anyway,
yes.
Okay. Anyway, I can anticipate that both the identity server and the security server are BFF APIs. Let me see if I can find the slide. Yeah, it's not very visible, but maybe I can show it you on a live server.
The reason why I'm asking right now, because around 5 o'clock I have to go, and I don't think that I'll be present.
No problem. Okay, so if you go inside IIS, this one called the out server is actually the identity server.
Okay.
Okay, and security, I think, is down there. SM.I.LE80 security is the security server. So this is the one that takes care of authorization, sorry. And this one takes the token requests and verifies the credentials. So they're actually hosted on IIS as well.
And the same question is for the report config Windows client.
Okay, that one is different because reporting configuration client is actually a standalone application. It's not running as a service. So you could actually install it on whatever server. What we usually recommend is to install it on core server 1, because core server 1 hosts the reporting and automatic reporting services. So we install it on usually in core server 1, and when you install the report configuration tool, you have automatically, I think this one, you have an icon created, a shortcut created automatically, so you can start it.
Perfect. And I have a couple questions too.
Sure.
First is related to the API gateway.
Yes.
My question was, is the API gateway, it route the request by itself, or it will use the balancer to do that?
I think it's better to ask Giuseppe.
Hello.
Giuseppe, can you repeat?
Hello. Yes. So we'll see also this part in the next model, but I can anticipate that. So the API gateway is called by a load balancer Nginx, and it's used to as is shown in the picture as a multiplexer for send the request to the correctly API service. So we can consider that. We'll see also in the next model. We can consider Nginx at machine level, and as a load balancer and Revex proxy at machine level, but API gateway is a Revex proxy and load balancer at application level.
Okay, and so it will basically use API gateway will at the low level will use the load balancer to find out. I mean, it will require also the load balancer to work. And another question is about it's about the LGV system. If you can go to the slide about that.
This one.
My question is what's the reason? Because there are two communication protocol, one using WCF and the other one using Rabbit.
Yeah, it's a good question. The WCF is a direct connection that actually it's the main one. So they are actually communicating through WCF. So this is the real communication. The communication with RabbitMQ actually are, they say that LGV system does not use RabbitMQ to communicate with LGV manager, but it is a sort of general infrastructure. So all APIs actually are connected with RabbitMQ, and the backend services are also connected with RabbitMQ. So I draw it here, but it's not really used for the main communication between these two components.
Okay, so it's using the usual, the one that we use also right now. The WCF is the main communication.
Yes,
and
absolutely.
there are some plan to move that on Rabbit or.
I don't know. I don't think there is a plan to remove this communication. I'm not aware of it. Yeah.
And why the transport system is still using the shared table? Just curiosity.
Okay.
Actually the transfer system is not part of SM.I.LE80 system. So SM.I.LE80 package. Maybe in the future. I think that we can take it. Actually, it's not part of the SM.I.LE80 package. So it's part of 80 system, but not of the SM.I.LE80 in the specific SM.I.LE80 package.
And very last question from me about the handling system. The next slide. Yeah, it's seen that there is a reference through the layout service to Smart.
Yes.
But it's a matter of mainly to just understanding, because to me it was more related to the LGV service, this communication. I don't know why it's instead related to the handling system that basically handled all the let's say crane and smart store scenario.
I don't know. I think it's a kind of historical reasons. I don't know if Giuseppe knows about it, because I think you're right, because I think that handling systems was designed to do more than just manage HDSM.
Okay.
But I'm not sure why handling systems, so it doesn't seem to be related.
Yes, maybe the idea is to move on the only one API service to manage these different connection to handling systems like LGV Manager and HA and SM. And yes, actually we maintain the separate part with the LGV Manager and HDSM.
So for the moment, it's designed in this way, but it could change in the future, let's say.
Okay.
Anyone else? Any other question? Okay, so I think we can start with the second session that is presented by Giuseppe. That is actually it's the completion of this session, because you will see how all these modules are actually deployed on a real systems, how they are distributed on different machines, and all of that. So I think it will complete the big picture. Okay, Giuseppe, if you want.
Okay. Hello, everyone. I want to share just a second. Do you see my screen? So Enrico, do you start the recording or?
Recording is started.
Okay. So in this module, we'll see the deployment architecture. So how the components are distributed in the system and the role that they play in the system. So we can consider the SM.I.LE80 system as a distributed system where a collection of interconnected machine and application work together to achieve a common goal. The system is designed to improve the performance and the reliability by spreading the workload across multiple application and machine. So we can consider the type of deployment configuration. A basic configuration that used for testing environment or a production environment, but without high availability functionality. And availability configuration used for production environment where it's necessary to manage also high availability. Before to see in detail the configuration, we can consider the types of machine that we have in the system. So we have the load balancer machines that host Nginx and use it for RX proxy and balancing. And this type of machine is a Linux machine that we'll see. And web server machine, the machine where the web UI is hosted and provided. The BFF that also in the previous model we already seen, the BFF backend for front-end server, where we we have the API layer that connects core application and the databases to the front end. So we have the core DB server, and so the machine where we can find the SQL Server instance. Core service server, the machine where we can find the E80 services like LGV Manager and the HDSM, SDM application, and so on. And another machine that we can define as an engineering station used to compile the code that you can find in the SM.I.LE80 solution. So as Giorgio said before, we have a closed artifact and the open code that you can find in SM.I.LE80 solution. The engineering station is not machine used in the system, but used only for compile and installation. Before to see the different type of configuration, let's talk about the third-party software that you can find in this SM.I.LE80 solution. So of course we have a Microsoft SQL Server 2029 standard edition, that you can find in Core DB server, and the Erlang OTP RabbitMQ that you can find in the all core servers, and for example one Core DB server for basic configuration, and all three core servers in the HA configuration. The net framework in the version 4.8 that you can find in the whole core server, and ASP.NET .NET Core Hosting Bundle necessary for BFF machine and other type of services like layout service that you can find also in the BFF server and core service machine, and the Visual Studio Build tool for building and compiling, and you can find in Engineering Station, and .NET SDK in Engineering Station necessary for compile. Docker, we can use Docker for deploy the web server Nginx that we can see next, that you can find in web server and load balancers. So of course Nginx in the version 1.20 and so on, web server, a load balancer machine, Minio, and Podman, but only for Red Hat Enterprise Linux operating system. So let's talk about basic configuration. As we can say, as a more simple configuration used especially for internal test setup where high availability is not required, and for production setup where the part of high availability is completely managed by customer. This solution requires 4 machines, a single machine web server, Linux machine where you can find the application like Nginx and the web UI, and these components are deployed as a Docker container, as we can see before. So a one BFF machine with API gateway, and we can find the API layer hosted on Microsoft IIS, and the two core servers, one with SQL Server and one with one for the services. Just an idea for the requirement necessary for this type of system. So starting from web server, we consider to have two possible operating systems: Ubuntu Linux 22.04 LTS or Red Hat Enterprise Linux in version 9.1. So about the resources, it's necessary to have at least one CPU with 4 cores and RAM 16 gigabyte, and 200 gigabytes for also operating systems and container Docker, and for the part of Minio that we can see also next. So about the BFF server, we have the Microsoft Windows Server 2022 edition, and with one CPU with at least 10 cores and 64 gigabyte and 100 gigabyte. And the core server 1, where the SQL Server is hosted, and with 2 CPU with 10 cores, RAM 64 gigabyte, and a different type of drives that it's necessary to have for services, the C for services and application and operating system, the D for databases, E for database logs, and F for backups of databases. Core Server 2, it's similar to Core Server 1, but used especially for services. So in this case, we have only one database where the services and operating system is present. About the internal test environment, so of course, it's more simple and less resources are necessary. We have 4 machine, one for web server, and typically used is Ubuntu Linux for this type of environment, but also Red Hat is possible. So we have one CPU, a RAM 80 gigabytes and 80 gigabytes for storage. So we have BFF server and of course MS Windows Server 2022 version, and Core Server 1 for databases and Core Server 2 for service. Okay, and let's see about different component and how the component are deployed and on which machine. So we have different type of databases in the system. Especially we have the SDM database, the SDM history used for historical data, and for example about transport order and information about shipping and so on, so historical data. So the database related to LGV Manager, and HDSM database, a database related to security, and where we can find information about users and permission, but also tokens, and we can see also in the next module tokens and claim related to role and permission. And another important database is a client configuration database that used for web UI configuration. This database we can find information about the pages, the configuration of the pages, the menu, dictionary, and so on. About component on core machine. So we suggest to have SDM application on the Core Server 1, LGV Manager application on the Core Server 2, the machine used for core service, Smart on Core Server 2, and the Smart Event also on Core Server 2, and layout service, it's the same, and reporting tool we suggest to host it on Core Server 1. This is the distribution for core application on the core servers. So continue to other components like BFF platform, and of course on BFF machine, BFF projects, and out server that based on identity 4. Also we can see it better in the next module, and security servers that used for managing users role, permission, and claim. The dashboard web hosted on web server machine Nginx, and Minio. So let's see in more detail the specific component, how is deployed on the machine, how is configured. So one important component of the system is Nginx, as we said, that is popular open source web server that sit between client devices and application servers and direct incoming requests to appropriate backend servers and application. So the scope of Nginx as a reverse proxy is to forward the request to appropriate web server based on URL path. The servers process the request and send the response back to Nginx, which in turn send the response to the client in the specific web browser. So in our solution, Nginx is deployed as a Docker container. Just to have an idea, Docker container is a lightweight, standalone, and executable software that includes all necessary or everything needed to run an application, including code, libraries, dependencies, and system tool. So it's not necessary to install or configure the system to run a solution under Docker container, but the container, in the specific, the image, contain all necessary to run the application. And in this slide, we can see the one of the most common command to check the status of a container Docker and PS, the specific. So in this case, we have Docker PS filter on the name of the container, and in the image we can see that the name of the image used to run the container, in the specific the status in this case up 5 days, it means that all is okay, and the port used to map to the port used for the application. So about web UI, we can see that web UI is composed by two applications. The dashboard web, that is a standard web UI accessible via web browser, that if you try to connect to the system, you can see the web UI. But another important component is the API client, because the API client is the link between the API, so the API service, and the web UI. So we the scope of the API client is to provide the BFF APIs list and detail to web UI. Like Nginx, in our solution, the two applications are deployed as a Docker container on a web server machine. In this case, also similar to Nginx, to see the status, is possible to use this command Docker PS and filter. And like Nginx, we can see the image, the status, and the port used by the application. So another component deployed on the web server machine is Minio. Just to have an idea, Minio is open source, high performance distributed object storage system. In our system is used especially to upload image by user. And it's deployed as in our system as a simple container, a single container, where all necessary components like a server and also a management console are deployed. So you can find the same command that we saw before, the Docker PS with the filter, where you can see the status of Minio. So just to recap, on machine web server, we have four Docker container. So the Nginx container for reverse proxying, the dashboard web, API client, and Minio application. About BFF that George also explained before, so we can say that the BFF is the API layer that refer to the set of protocol and services that allow the different system software to communicate each other. In the specific, the core service and database with the web UI. The BFF is based on IIS and the ASP.NET Core module. In the specific, it allows the application to work with IIS, and the scope is to run ASP.NET Core application with IIS by hosting an ASP.NET Core app inside the IIS worker process, called the in-process hosting model. So, and it's simple to see this feature because if try to open the task manager, you see a lot of these VP.x application executed on the system. So this is the management page of IIS. Giorgio already explained before, and the different BFF API. So in our system, all BFF API and the part related to identity server, so authentication and the security and API gateway are hosted on BFF machine. Just some word about the API gateway Ocelot. That is an important component. So the scope is to centralize the request to BFF service and distribute the request to proper site. So like Nginx, it acts as a Revex proxy. But while Nginx act at the level machine, we can say that API gateway act at application machine. Another scope of API gateway is for diagnostic reason, because in fact the role of API gateway is also to interrogate all application and show a report about the status of all application. You can see also this status on the web UI machine. About the settings, the API gateway is configured by Ocelot files. That this should be done creating one single file of files for each service connected to the gateway. So for each BFF API that you can see in IIS, we have a specific Ocelot file in a specific folder of API gateway named Ocelot, and this is the type of Ocelot file. So we have the downstream path template, so the path called by API gateway, and the upstream path template is the incoming, is related to the incoming request. So in the specific in this case, we have the name is the path is similar, but it's possible also to change the path of downstream respect the upstream. So the upstream HTTP method is the filter of the accepted request by API gateway, and this is information about load balancer that we can see in the next next. A downstream host and port is in the specific the host and the port that the request should be redirected by API gateway. So as Giorgio said before, the BFF is installed in one single folder, but we have also a single folder for configuration, and the name is pub www.root SM.I.LE80 shared settings. In this folder, we can find four files. One for the connection strings.json that contain all connection string to databases. The connection string.vault.json that contain login and password to access to databases, and also we can see in the next module is encrypted, and is encrypted with an algorithm of SHA 256. So a general setting .json contains configuration for RabbitMQ, out server, and connection to Minio. And general setting .vault.json, it's the same of connection string .vault.json and contains information about login and password to access to service like RabbitMQ and Minio. It's encrypted also. The choice to have different type of files is for the cybersecurity manner and for to have the possibility to encrypt completely the file for security. So just some word about core services and where are located. The services are installed like Windows services and deployed in the same in a single folder C program files E80 group. So we have the SDM application on core server 1, and the SDM application is based on .NET Framework 4.8, LGV Manager on core server 2, .NET Framework 4.8, HDSM application that is on core server 2, or the same is .NET Framework 4.8. Smart Event is core server 2. Like LGV Manager, like HSM, it's based on .NET Framework 4.8. Layout service, it's core server 2 and based on .NET Core 6, and the reporting tool, as we saw before, and on core server 1, and it's based on .NET Framework 4.8. So just to recap, and about the basic configuration. So the basic configuration, it's a more simple configuration that used for internal test and in the system or production system where the high availability is completely managed by the customer, is composed by 4 machines. One machine that named web server, that contain the Nginx, the dashboard web, API client, and Minio. It's a Linux machine, Ubuntu server, another 3 machine, Windows server, BFF, and Core DB machine, Core server 1 and Core server 2. Okay, so let's move to HA configuration. So the SM.I.LE80 system is designed to ensure that a system is always available and with minimal downtime and data loss. So it relies on redundancy of machine and automated failover mechanism. In fact, the use of different type of machine, so we have a redundancy of machine, make the system resilient about against every more of failure. So to achieve this this purpose, in the specific services and the database run on Windows failover cluster, and other components like web server, BFF are deployed on two virtual machine, both for redundancy and the load balancing. So the core service machine, actually we have three core service machine are linked together with a Windows cluster. This for high availability feature. And about other level, we have two type of machine, BFF and two-type machine web server and two-type machine load balancer. So the difference in this case that in Windows cluster we have only application active at time on one of these three machines, but in at this level all applications are active. So we have a configuration active. So the system is composed by 9 machines, 2 load balancer, two web server, 2 BFF, and 3 core servers. So about the HA configuration, the important things that the machine must be distributed. So the virtual machine must be distributed on the 3 physical hosts based on type. So, for example, the load balancer, web server, and core server should be distributed on so the load balancer 1 and load balancer 2 so 1 and 2 should be distributed on 2 different physical hosts. So with this type of configuration is possible to support the failure of a single VM and all VM and also an entire physical type host. For example, in this case we have that load balancer fails, BFF fails, web server fails, and one core server fails, but the system continue to work properly. Okay, just an idea about the requirement of this type of solution. So we say that we need 2 types of machine for load balancer. Ubuntu Linux, like basic configuration. It's the same about the resource. Web server machine, 2 types, two machines. Ubuntu Linux 22.04, like basic configuration. Web server machine the same, and but 2, and core server 1 and core server 2 that SQL server is hosted on both, and the core server 3 machine without SQL server. So important role in the system in the HA configuration is DNS. So the DNS type A is a type of resource recorded in the domain name system that maps, the scope is to map the domain name to an IP address. The A record is one of the most common DNS and is used to translate the domain name to a list of IP address. So it's important for DNS because also to access to the system via a domain name, but also for availability reason, because the web browser switch on the correct IP address is the one of the two machines are not available. So it's necessary also for availability reason. So in HA configuration, Nginx plays a crucial role in terms not only of reliability, like a regex proxy, but also for distributing the request to valid server. So for also for performance reason. So in fact, the scope in this case is to distribute the incoming network requests across multiple servers to avoid that the system becomes overwhelmed. For this purpose, Nginx uses the round-robin algorithm to distribute incoming traffic. This means very simple that each server in the pools or in the specific, in our case, we have a web server 1, web server 2, BFF1, BFF2, receive the equal number of requests. Okay, in HA configuration, also the API gateway is very important because also as regex proxy we saw before, it's used also for a load balancer. So in our system we have a redundancy about load balancer layers. So it distributes incoming requests across multiple backend services using load balancer algorithm as round robin like Nginx. So the scope in this case is to have a double layer of load balancer. So an Nginx used for distribute the request to different machine and balancing the request to the different machine, and Ocelot to distribute the request to different applications. So it works at application level. So this guarantee that the availability is not only in availability at machine level, but also on application level. This means that if one application fails, but not the entire machine, but only some of BFF services, the system continues to work properly. And how configure the BFF to for load balancer feature? So we have the Ocelot files that are that we saw before, and we have the downstream path template. It's the same part that we already seen. The different things is related to this part and this section downstream host and port, where you can find two records, one for the host 1 and one for the host 2. So this is specific. This is related to BFF machine 1 and BFF machine 2 with the specific port. Okay, let's move to core machines and the distribution of the components on the machine. So we have the databases. If you remember, we have different type of databases: SDM mystery, and LGV manager, and HDSM. Security, client configuration, all of these databases are distributed on core machine 1 for this primary, we can see primary machine, and core server 2 that used especially for backup. The SDM application is hosted on core server 1 and core server 2. The LGV manager is mainly run on core server 3. But core server 2 also for backup, and HDSM it's the same of LGV manager, and smart event, layout service, and ubiquity the same on core server 2 and core server 3. And at the end, we have the reporting tools like reporting service and automatic reporting tool that is hosted on core server or core server 1 and core server 2. So to have availability feature, the the Windows failover cluster is used. a failover cluster of window. It's a group of 2 or more machines that work together to increase the availability of application and services. Important in the high availability in the failover clusters is the concept of role. That provides a seamless failover or resources from one node to another in case of failure. So the role includes one or more resources that can be physically resources like disk or networks, or network interfaces, or virtual such as application services or IP address. So the resources in the failover cluster are managed by cluster service, which monitors the health of each resource and initiates the failover process when necessary. When a resource fails, the cluster service automatically moves to another resource on another node in the cluster that supports it. So in our system, we use failover cluster for core application and databases, and this used for increased high availability. Okay, and this is an example of failover cluster manager, and with the 3 nodes that we have in the system, 3 nodes of core servers, and with the different role that we have on the system. So it's suggested to install the failover cluster in Active Directory domain, and to use the same domain user to configure the system and install it on the different machine. As we said, to achieve the high availability for databases, it's used the feature always on of Microsoft. It's based also on failover cluster. So SQL. Sorry.
No, if I could.
Okay. SQL Server always on assure that the database are always.
Do this, look, вот здесь вот. Здесь где-то так вот пришпандерить.
Sorry, can you mute, please? Okay. The SQL Server always on ensure that databases are always available for the system, and it provides a feature and technology that help to achieve the high availability and disaster recovery for databases. The always-on solution in the specific typically include 2 nodes, where each node can host a replica of the database. The primary node is the active in the specific, and which receive all transaction and update to the database. The secondary node in the system is the passive replica that maintains a copy of the primary database and provide the automatic failover and load balancer capability, but typically we use for automatic failover when necessary. So in the event of a failover on the primary node, the always-on solution switch automatically to secondary database, and this is it's very important to provide the high availability of the system. And in this screen, you can see an example with 2 machine, where the first machine is the primary machine used to update databases, and this is the typical configuration with synchronous commit, automatic for failover mode, connection in primary role allow all connection, readable secondary no, and seeding mode automatic. Okay, let's let's to at this point to consider the role of cluster, of failover cluster, and how they are distributed on the system. So this is the name used automatically by SM.I.LE80 system during the installation, but it's possible to configure the naming. And we have the E80 SVC smart role. It's related to the role for smart event and layout service that it's configured on Core Server 2 and Core Server 3 especially. So E80 availability group SDM is the role for the availability group related to the SDM database. The E80 SVC SDM is the role for the application SDM application, and E80 AG LGVM it's the role for the LGV manager database, and it's the same E80 SVC LGVM it's the role for the application LGV manager. Another role is the E80 AG SDM history for the SDM history database, and this the E80 SVC RPT is the role for the reporting service tool, and E80 AG sec Y it's the role for the security database, and then we have the role for the client configuration database for the HDSM database and for the HDSM application. And we have a single role for the each database, but for the application we have also a role that contains different resources. For example, the smart role contains different resources like smart event and layout service, and also the reporting role contains different role for reporting service and automatic reporting service. So as we saw before, one of the important component of the system is the RabbitMQ. So RabbitMQ it's used for communication between the different component of the system, like LGV manager and SDM, and also between BFF application, BFF services. And in the HA configuration, we have a RabbitMQ cluster. RabbitMQ cluster is a group of RabbitMQ nodes that are interconnected and share the same logical message broker. When the RabbitMQ cluster is configured, we have multiple nodes that provide that work together to provide a highly messaging system. So the node communicate each other to ensure that messages are delivered to the correct destination. And with a RabbitMQ cluster, it achieved the high availability and fault tolerance by assuring that the messages are always available, even if some node fails. For this purpose, one important role is played by the quorum queue. So about the quorum queue, provide a strong consistency by ensuring that all replicas of messages are written to disk before acknowledging the messages. This is very important because in case of failure of one node, considered to have 3 nodes in our system, the current queue will automatically elect a new leader and continue to processing the message without any disruption. So it's important to continue to have the continue of the work of the system. So another important thing is that the quorum queues are designed to handle large volumes of messages, and are well studied for high throughput use cases. In this example, you can see three types of quorum queue that we have in the system. So, for example, the LGV to WMS queue, the WMS to HDSM queue, and the WMS to LGV queue. This is the queue used by LGV manager to send message to WMS, and for example, this is the queue used by WMS to send messages to LGV manager. Okay, let's recap about the HA system, and so it's a system that provide feature about failover and high availability, and it's the solution designed for increase forever the optimal performance of the system, and forever a feature of availability, of course. It's composed by 9 machines, 3 core servers that are linked together by Windows cluster feature of Windows and of Microsoft, and 2 types of machine for load balancer, and 2 type of machine of BFF, and 2 machine for web servers. This type of machine, the application of this machine are always active, and it's used the model active with load balancing distribution on this type of machine. Okay. So one goal about SM.I.LE80 is to spread the DevOps culture, and to help you to improve the efficiency and the effectiveness of software development, and especially delivery. So there are 2 keys important about DevOps, and continuous integration and continuous deployment. So about the continuous integration, you can see a definition is a practice of automatically building changes as soon as they are committed to a version control repository, such as Git. In specific case, we use Azure DevOps and Git. So because this is important, because this helps to catch issues early in the development cycle before they become bigger problems. It also encourages developers to integrate their changes frequently, which reduces the risk of conflict and makes it easier to identify and fix issues. So another important thing is the continuous deployment, and it's the process that one step further by automatically deploying the changes that have been tested and approved by the CI process to a production environment. In our case, it's not production environment, but typically internal environment for testing. So it's important because this allows the teams to release new feature and bug fixes quickly and reliable without need manual intervention. So typically the manual intervention, it's possible to have some problems on error. The use of continuous deployment reduce this error level. So when you start to work on a SM.I.LE80 system, it's you can find also different pipelines, and in this specific, the continuous integration pipeline for SDM, for the CDM application, LGV manager application, and LGV manager application, and HDSM application, and BFF project in specific. So we talk about the application that you can find in open source mode. Another thing that another point that we encourage to use the pull request mechanism during project developing for different scopes. One is very important, is for code review, because this give possibility to improve the code quality. Another important thing also is for the collaboration, because pull requests facilitate the collaboration among the team members. So about the pull request, for example, typically a trigger, so the open a pull request, the pull request trigger the pipeline for continuous integration to check the status of code, so the fact that the code at least compiles. Another thing that triggers the pipeline of continuous integration is the merge on main branch. So the scope in this case is to check the build, so the compile and the creation of artifact. Another pipeline that you can find in the system is the pipeline of deployment for BFF project. This pipeline is used to deploy automatically the content, the artifact for the BFF project on the testing environment system, and it's triggered by the BFF continuous integration pipeline that trigger a process of update of the system. So in the specific, the pipeline will update with the new content the test environment, reconfigure correctly the system to work properly after the new content, the update, and then update also the web UI based on of the new API. If you remember, there are a component in the web UI named the API client that contains the definition of API necessary to have to link them in the web UI. So to view the new API or changes on the API, it's necessary to update API client. It's done automatically by pipeline. So I completed the module. I don't know if think that we can stop the recording and
any questions?
Yeah, any question?
If nobody answer, I have a question. What's the reason of the Linux machine? I mean, it's in order to handle the Docker container, or there is other reason?
Yes. So actually, the scope of the Linux machine is to it's to move to a type of system that based on Docker or on Docker containers, and it's with the Linux machine it's more simple to manage it.
So basically, it's for NGX and something else, or there is other.
Yeah. So about Docker, it's used. About Docker, it's actually we use for Nginx as I said, but also for web UI, and in this specific we have 4 Docker containers. One for Nginx, one for dashboard web for the web UI, the API client application, and Minio application.
So you said NGNX. What about the other three? Sorry.
Yeah, so the NGNX, another component is the dashboard web, the web UI. So NGNX, I don't know if you remember the previous module, but NGNX it's used at the first layer where the web browser access to use it for accessing to the system. Okay, then we have
clear.
Yeah, okay. Then we have other application. So the dashboard web, the web UI. So at the end, it's based also on the Nginx. But it's a separated container. So we have a container for I can show you on the, for example, on our system. Just a second. So, for example, we have the Nginx. It's the load balancer. The specific for this configuration, it's only Revex proxy. So Nginx, and we have the dashboard web. This one. Okay, the dashboard web.
Giuseppe, can you make the font a bit larger? I think it's hard to read. It's very, very small. At least I see it very big.
I don't know if I can.
Okay.
So use PowerShell. Better or okay?
I think it's a bit better, yes.
Okay, and as I said, we have the Nginx component. Okay, it's only a Revex proxy, and it received the request from the web browser and redirected the request. It's very simple. So we have the dashboard web, the web UI. It's a this is another Docker container, and we have the API client that I explained in the module, and the Minio. So at the end, it's very simple because the dashboard web it's also based on Nginx, but we have the effective site with all files and so on in the image and in the container. I don't know if it's clear. No.
Yeah, now it's more clear. For sure, it's not probably 100%, but makes sense because it's a lot of stuff for now. But yeah.
Okay.
I have a question about the license service, because what I understand now is something like the license service is not existing, yeah?
No. Actually, no. We don't have a licensing server for licensing service for SM.I.LE80 system.
So right now, theoretically, you can connect as many as want user, yeah, to our system. It's not limited.
No. It's the scope of also of user web browser. So it's different approach from the client, the previous client.
Okay. Thank you.
Other question?
Yeah. What about one for me again? What is the, let's say, starting from the web browser? What's the sequence of all, let's say, the components that get hit while in sequence?
Yeah, good question. So consider this type of configuration. We have the web browser, okay, and I digit the link for the system, for example, an IP address, and I can show you. For example, here, okay. This one. So when I click on enter, the request is moved to Nginx. Sorry. So it's moved to Nginx. This is the component Nginx on this machine, okay? And the Nginx move the request to the other component of this machine, in the specific the dashboard web, and then the request is sent back to the web browser. So the scope in this case is to download the dashboard web. In the dashboard web, I have configured a different type of. I have all information about the path necessary to invoke the API and other type of information. And so all requests that start from the web browser pass through the Nginx and then do the BFF. So the dashboard web is used only when I send the request to download the dashboard web. For example, I want to show you. So now, okay. Okay, this is the network, and for example, I want to log in to the system. Okay, and these are all requests, for example, and invocation, an invocation API. But this invocation, this request pass through Nginx that send the request to the correct API. And the specific send the request to API gateway, if you remember, and then the API gateway send the request to the specific API service. In the specific, in our case, the security service. I hope that it's clear. I don't know, but something.
I mean, yes, for sure. The browser Nginx, then Nginx to the dashboard web.
Yeah,
the dashboard web
yes,
when it will basically call the API gateway. I'm correct.
Esatto. Allora, so the field. So when I send the request, for example, for this request from web browser, okay, I send the request to Nginx to download the web browser. So the Nginx send the request to dashboard web, and then I can download the
content of the page.
Exactly the content of the page. So in the page there are all information about the API path and so on. Okay, and all requests that start from the page from the web browser in the specific pass through the Nginx, and Nginx redirect to the BFF machine in the specific, because in this case we have the API this one path. So to BFF machine, and the BFF machine and the specific to API gateway or Ocelot. The Ocelot send to the request to the specific API in the specific LGV system in our case. Now, if you remember LGV system that Giorgio before explained the scope of LGV system API. So the API send back the request, so the response to API gateway. The API gateway send the response to Nginx. Nginx send the response to web browser.
Okay.
So it's more complicated. It seems more complicated, but it's not real not. But it's complicated only to explain the sequence of different call. But it's common to have in web application this type of solution. Okay. So the scope of Nginx, it's to Revex proxy and load balancer for HA, but another scope is to have a first layer of interface between the web browser and the system. So this is possible also for security reason to have only a single layer for communication between the web browser and the other application. So it's necessary also to protect the application and the services and database.
Okay.
Other question?
Okay, I think we can close the module, Giuseppe. Maybe okay. I don't know if Enrico
Thank you all.
Thanks a lot, Giuseppe. If Enrico agrees, maybe we can take 5 minutes break.
Yes, I suggest to have a 5-minute coffee break.
Okay, so we will meet again in 5 minutes from now, and for sure I will be able to catch up sometime because for installation I can go a bit faster than planned, so that we will recover a bit of delay we have. Okay.
Okay.
Okay, so see you in 5 minutes. See you later.